All right, back on section 5-4, some more problems. 6, 7 at least. Maybe we'll go 6, 7, 9 if I can squeeze them in. Number 6 says a rectangle has its base on the x-axis, and its upper two vertices on the parabola y equals 12 minus x squared. So a really rough picture. Y equals 12 minus x squared. So I got this rectangle that has its... So here's the basic idea, right? It doesn't really say this. It probably should say this, but that rectangle has to be centered around the x-axis. Otherwise, it's not going to work trying to figure out the equation. We're trying to maximize the area of that rectangle. Okay. So when I do these problems, I always write down what I'm trying to maximize, the area of the rectangle. So generally speaking, the area of a rectangle, is length times width, right? So what we're going to do is we're going to look at this picture. We're going to call this the length right there. So this little part here would be x. And if that's x, I just call that x because it's the distance from the origin along the x-axis. Then this height here has to be y. Okay. So my area of the rectangle is length times width. The length is 2x and the height is y. Just like all the other problems. So typically that's the hardest part of the problem, is just setting up that equation. The math, the derivatives usually aren't too hard here. Sometimes they're a little tricky like that last one. Now we would want to, we need a relationship between x and y, but we got it right there. Nice and easy one. So area equals 2x times y, which is 12 minus x squared. I'm just going to go ahead and multiply this out. So 24x minus 2x cubed. That's what I'm trying to maximize. Take the derivative. 24 minus 6x squared. Set that derivative equal to 0. 6x squared equals 24. X squared equals 4. X equals plus or minus 2. Again, just to double check, we could put 2 in here. We don't need to worry about the negative 2. That's just a domain thing. X has to be positive, right? So before 2, like 1, we put that into the derivative, like right here. 24 minus 6 would be positive. After 2, like 3. 3 squared would be 9. Figure would be really big, so that would be negative. So you have a maximum at x equals 2. You can check the endpoints too. But the thing is, if there's only one turning point also, it's either a minimum or a maximum. You don't have to worry about the endpoints. All right, the question, make sure we answer the question, said what is the largest area? I guess that means area, right? Or what is the largest area? So we got to put that back. Put that back into my, sorry about that. Put that back into my formula for area, which is 2x times 12 minus x squared. 2 times 2 is 4. 12 minus 4 is 8. Looks like the biggest area is 32. So that's problem number 6. Next, we'll go to problem number 7. Problem number 7, you're planning to make an open rectangular box. This is similar, I think, to probably, hopefully, I did these earlier, but one of my examples. We're trying to make an open box. We got an 8 by 15 piece of cardboard, and we're going to cut those corners and fold it up. And we're going to find the dimensions of the largest volume. So I'm going to change colors here a little bit. We're just going to call that x. We'll call that x. And so we're trying to maximize the volume of this box when I fold it up, which will be length times width times height. So the length of that box, or width, it doesn't matter which, is this right here, because when you fold that up, that's going to be one of them. So that's going to be 15 minus 2x. The height of that box is going to be that right there, which is going to be 8 minus 2x for the same reason. And the height of the box is going to be those little squares, which is just x. So again, there's my formula. That's what I'm trying to maximize. I'm going to multiply it out first. Make sure I don't make any mistakes here in the math. So 15 times 8 is 120. And then I got a minus 16x. I'll just write it out so I don't make any mistakes. And then I got minus 30x. And then I got plus 4x squared. And then times the x. So I'm going to distribute it. 120x minus 46x squared plus 4x cubed. take the derivative because we're trying to find the critical points. 120 minus 92x plus 12x squared. One thing you can do, I probably said this, but I'll just say it again, is if you need a calculator, go ahead and use a calculator to solve things. Totally fine. Just adding, subtracting, multiplying, and dividing. So we want to set this equal to 0. It's not very pretty in terms of factoring. I'm just going to do the quadratic formula. Let's just do the quadratic formula just because we can. And we could probably try to reduce this. Let's see, 12 does not go into 92, so that's not going to be a lot. I could divide by 2, get a little bit better. I'm just going to do the quadratic formula. So it's opposite of b, which is 92, plus or minus the square root of b squared minus 4 times a times c all over 2a, which is 24. A little calculator work here. 92 squared minus 4 times 12 times 120. And hopefully we'll get a little bit lucky here. We take the square root of that number. And we get 52. Look at that. 92 plus or minus 52 over 24. So we got two different answers here, remember. I got 92 plus 52 divided by 24, which is 6. And then we got 92 minus 52 divided by 24, which is 1 2/3. So those are my two critical points, 1 2/3 and 6. So theoretically, one of them might be giving me a minimum, might be giving me a maximum. But we do have an issue with domain. Even if you think about it, check this out. Back to this, the biggest x can possibly be is 4 because the side of that length is 8. So it's 4 and 4, so you can't even have this 6. So that's a useless answer. So this is probably going to be my answer, yeah? But we can just double check it. You put a number a little bit to the left. We got to put it into the derivative. Remember, here's my derivative, 120 minus 92x plus 12x squared. So we put 1 into that. It looks like that's going to be a positive number, right? 120 minus 92 plus 12. Anything bigger than that, like 2. 2 squared is 448. So I think we're negative because that, let me make sure I got that right. Just to make sure I didn't make a mistake, we'll put a 2 in there. We'll get 120 minus 92. Yeah, I think we're good. 92 plus 12 times 4. Definitely get a negative number. So we got a maximum at x equals 1 2/3. And the question is, what are the dimensions of the box? So that's my x, right? So we'll go 1 2/3. And then I got to double that and then subtract from 15 and subtract from 8, right? So we're going to go back to the 15 minus 2x for the other sides, right? So I don't want to make a mistake here. So we'll go 1 2/3. We'll go 15 minus 2 times. So I got 11 2/3, I think, on the other one. And then we'll go to 8. And we get 4 2/3. So those are the dimensions of the box. If I got that one right, look for the video on the next one because that's long enough there.